Particles less than atom. Physicists constantly look for new particles, and when they find them, they categorize them. They try to find patterns that tell us about how the fundamental building blocks of the universe interact. The word fundamental means objects that are simple and structureless, not made of anything smaller. In particle physics, an elementary particle or fundamental particle is a subatomic particle that is not composed of other particles. Scientists have discovered about 200 particles, most of which aren't fundamental. They used letters from the Greek and Roman alphabets for the names of these particles. Experiments that looked inside an atom using particle probes indicated that it had structure and was not just squishy balls. These experiments helped scientists determine that atoms have a tiny but dense positive nucleus and a cloud of negative electrons. Initially, scientists thought the nucleus was fundamental because it appeared small, solid, and dense. Later, they discovered that it consisted of positively charged protons and no-charge neutrons. Physicists have discovered that protons and neutrons are composed of even smaller particles called quarks. Quarks are like points in geometry. They're not made up of anything else. After extensive tests, scientists now suspect that quarks, the electron and a few other particles are fundamental. Electrons are in constant motion around the nucleus. Protons and neutrons jiggle within the nucleus. Quarks jiggle within the protons and neutrons. If the protons and neutrons in the diagram were 10 centimeters across, then the quarks and electrons would be less than 0.1 millimeters in size and the entire atom would be about 10 kilometers across. 99.99999999999% of an atom's volume is just empty space. While an atom is tiny, the nucleus is 10,000 times smaller than the atom and the quarks and electrons are at least 10,000 times smaller than that. We don't know exactly how small quarks and electrons are, they are definitely smaller than 10 to the power minus 18 meters, and they might literally be points, but we do not know. It is also possible that quarks, electrons, and other currently known subatomic particles are not fundamental after all. Will it turn out to be made up of other, more fundamental particles? Only time will tell.